All right, that looks better. Okay, I lost the power went out, lost, it turned off everything, but we're back. So you can look at the end and you can see the problem, but basically it was talking about the magnitude of a star was shown by the function as shown, and we did the period, and they wanted to know when was the magnitude of the star 15. Let me see if I can find the problem so that we can let's see what it did. What that do it? I don't think it's gonna show me that. Nope. Ooh, I'm trying to get back to it, but I'm not gonna spend too much time doing that if it isn't cooperating. Ooh, can I print it? No. Let's just go. Sorry about that. This thing is being difficult. Preview. We were on number. Of course, the problem looks different. We'll just do it. We'll just do it again. We'll just do it again. This will do it. See if that works. All right, so here we go. It says that suppose the height. It's completely different. The height above ground of a person sitting on a Ferris wheel is described by the following: H of t. This is 13. H of t is equal to. That's not good. So autofocus. Backing up. That's not clear. There we go. H of t is equal to 18.7 minus 16.6 cosine of 2 pi over 5t. In this equation, h of t is the height above ground in meters, and t is the time in minutes. The ride begins at t is equal to 0 minutes. That makes sense. In the first 5 minutes of the ride, when will the person be 27 meters above the ground? So, 27 is equal to 18.7 minus 16.6 cosine of, cosine of 2 pi over 5t. Now, the period of this, as I showed at the beginning of the problem when I started it before, the period of this is 5. Because it's 2 pi over 2 pi over 2 pi over 5. All right, that simplifies to 5. So we're looking for two answers, but we have to make it make sense. Think about what a cosine graph looks like. It starts here. It goes up, then down. Looks roughly like that. 1, 2, 3, 4. It divides into 4 parts. So whatever the period is, you can divide the period, which is 5. And again, I didn't show the shift because it's shifted up. And it's inversed, so it's upside down. But this is just to give you an idea of what we're doing. If that's 5, that's 2.5. That's 1.25. And this is 3.75. And the reason why we're doing this is to give us an idea of what we're looking for. So actual function would probably be inverted like that. So if it's above, we're looking between 2.5 and 5 is what we're looking for this height to be. What is that height? 27. Sorry about this focus. I don't know why it's acting up. Also, if you have any questions, be sure to type them in the chat. All right, so let's go. So 27 minus 18.7. So 8.3 is equal to negative 16.6 cosine of 2 pi over 5t divided by negative 16.6. So negative 0.5 is equal to cosine of 2 pi over 5t. Okay. So there are two places that cosine is equal to negative 1/2. We did this earlier. Cosine is equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. Cosine is 1/2 there. So sorry about all the yawning. Got kind of sleepy there. So if we take the arc cosine on both sides, we get 2 pi. Well, let's do it like this. Let's do it like this. Negative 0.5 is equal to cosine of 2 pi over 5t. We'll take the arc cosine of both sides. All right, and then we get just two answers. We end up with 2 pi over 3 is equal to 2 pi over 5t. And then we get 4 pi over 3 is equal to 2 pi over 5t. And technically this t is in the numerator. All right, so we're going to multiply both sides of this one by 5 over 2 pi. Actually, we're going to do it for both sides by 5 over 2 pi. And the reason that we're doing that is to get rid of the coefficient for this t. We want t by itself. So it goes away there. Here we end up with 5 over 3 is equal to t. And here we get 10 over 3 is equal to t. All right. So they ask us to what do you call this thing? Round to the nearest hundredth of a minute. Ugh. So 5 over 3 is 1 point round to the nearest hundredth. 6, 7. And here is 3.33. That sounds right in the first 5 minutes. Well, I mean, I was expecting it to be one of them to be, both of them to be greater than 2.5. With the OR button. Let me see. I'm not telling you all this, but I like to check my work, and I am right. So these are my answers. All right. Do y'all have any questions for me, or am I just continuing to do problems? Nobody told me nothing. I'm sorry. I didn't realize y'all couldn't see this. I didn't realize you couldn't see this. I don't know what's up with the focus of this thing. What is that? Oh. All right, let's do it. Let's just keep going. Let's 2 cosine theta minus root 2 is equal to 0. They want to know from 0 to 2 pi. Is it still blurry? All right, for this, while I'm waiting on the answer, 2 cosine theta is equal to root 2. It is still blurry. It looks clear. I'm looking on another, I have a video of me writing up, and I'm looking at it. It looks like it's fine to me. Yeah. All right, what about that? Better? All right, good deal. All right, so there we go. Is it still showing blurry? It should. Like I said, I'm looking at another video. I have the video up of me making a video. So, I mean, I see it. It looks okay to me. All right, let's keep going. Tell me if you can't see what I'm doing. All right. Where cosine theta is root 2 over 2, there are 2 places. So theta is equal to pi over 4 and 7 pi over 4. It's where cosine is positive. First quadrant and fourth. Yes. Test always opens at 12:01 a.m. and closes at 11:59 p.m. This is an interesting problem. Let's look at it. And if y'all done, let me know, because I'm getting old. It's time to go sleep. All right, so the lines here. We have here and here. This is 43 degrees. This is theta. This is 129 kilometers. This is 113 kilometers. This is C. That's B. That's A. So obviously this is a little way over here. This is little B over here. And this is little C right there. All right, an airplane leaves City A and flies 129 kilometers due north to City B, and then it turns at an angle of 43 degrees and flies 113 kilometers to City C. What angle theta with respect to due north could the pilot have used to fly directly from City A to City C using this figure? All right, so looking at this, and I drew it kind of a little big, but whatever. Looking at this, this looks like hold on, side, angle, angle, side. This is law of cosines. So we want to know this angle. So, but we don't have all the side lengths, but we don't need it. Okay, so first thing we want to find is this angle right here. So if this is 43, this is 137. Oops, 137 degrees. We have this side, and we have that side. That looks like law of cosines. We're trying to find this angle. And normally we have these two sides. That's weird. Side, we don't know that angle. Side, we don't know that angle. Angle, we don't know that side. Law of cosines. All right, so we got to do it 2 times. So b squared is equal to a squared plus c squared minus 2ac cosine of b. Yeah, I can see that. Right, so we don't know b squared. So b squared is equal to 113 squared plus 129 squared minus 2, 113, 129 cosine of 137 degrees. All right. Okay, I won't be lazy. 113 squared. So b squared is equal to 2769 plus 16641 minus 2 times 113 times 129 times 154 cosine of 137 degrees. Your calculator should actually be able to handle more than handle this. So 169 plus 166 41 plus 2 154 cosine of 137. And you get 50,700 and can you see that? I think you can. You get 50,700 and some odd number. I'm not going to round this. Okay, I'm just going to take the square root of this number. Square root of answer. And I get B is equal to, this is an intermediate, so 4 decimal places, 225.2374. All right. At this point, I have all 3 sides. Right. I have all 3 sides. So then I go sine of A over whatever A is, which is 113, is equal to sine of B, which is 137, over little b, which is this 225.2374. Again, normally I wouldn't round it at all, but they said I could, so I will. So very little algebra. Sine of big A is equal to 113 sine of 137 degrees over 225.2374. Your calculator can handle this. 113 sine of 137 over 225.2374. All right. And then I take the arc sine of whatever that is. So arc sine of my answer, and I end up with answer around to the nearest tenth of a degree. It still ends up being A equals 20 degrees. Get that? That's a proof. I'm not gonna do that. I'm not gonna do that one. If you have any specific questions, definitely feel free to ask them. That's more solving a triangle. We just got to finish doing that. Okay, we could do another little what do you call this thing? Exponents problem. And this is number 19 on my. I have 3y cubed over 2y to the negative 5. And all of that cubed. Deal with what's inside first. 3 on top, 2 on the bottom. That stays. All right, y to the negative 5th is a property that we use. 1 over a to the negative m is equal to a to the m. So this y to the negative 5 goes up and becomes y to the 5th. So I'll just do it like this. Y cubed times y to the 5th cubed. Some of these steps aren't necessary, but I'm doing them so you can see what I'm doing. So 3y to the 8th over 2 cubed. We're done inside of parentheses. Now we cube everything. 3 cubed is 27. Y to the 8th cubed is y to the 24th. And 2 cubed is 8. And that is that. All right. I cannot think of an instance where fractions, you can't simplify a fraction, and then when you square it or cube it, then you can simplify it after that. You can't do that. If you think about what it is, you can't do that. All right. Let's see what else we got here. We did a problem like that already. Yeah. Okay, we did a problem. Well, we didn't do a problem like this, but this is a graph on here. I would definitely advise you to check out the video. Well, it's kind of late now, but check out the video on homework number 12 when we talk about asymptotes. But you already watched videos, so you already know what's going on there. All right, I think that this might be all the different types of problems if y'all don't have any questions. I mean, we haven't covered, I wouldn't say that we covered every single thing. We've covered just about everything. So, what questions might you have for me? Hey, okay. With exponential graph transformation, do they follow similar rules as other graph transformations? Yes. Yes. So if a number is near the x, then it does the opposite of what it's supposed to do. If it's by itself, then if it's by itself, not with the x, then it moves up and down. You horizontal and vertical compressions and stretches and shrinks and all of that. It's the same stuff. If you have a problem that's like that you want to look at, we can do that if you want. Yes, the shrinking the the shrinking stretch. It always messes everybody up. If I'm honest, if we're honest, because it does the opposite of what it's supposed to do. What's going to come in front of me? But if you have any, could I just see any other description? So you haven't already. I haven't. I'm kind of going through these problems and seeing if I see anything like that. I mean, I have graphs of horizontal and vertical asymptotes. Um, I'm trying to see if there is a. I'm trying to see if there's. Do you mean like a word problem or like just a regular one? That ain't helpful. Oh, that's not right. Okay, here goes one. Let's see if this is clear. All right, so I have. I can see that g of x is equal to 3 raised to x plus 1. Ooh, that looks terrible. You mean one like this? That's still better. Yeah, there we go. Whew. Okay, so the question that they ask is how to graph it, asymptote, blah 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 blah. Okay, parent function for exponential function looks like that. Where this is 0, comma 1. And the next one is 1, comma whatever our base is. So this would be like 1, comma 3. If it was without the transformation. Okay, this plus 1 here means that this graph moves to the left 1. All right, so what it would look like, let's see. That goes over. That's good enough. Right. So if we do it again, and then I'll do a little table here, and that'll help show some. All right. Um, so this is y is equal to 3 to the x. This would be y is equal to 3 to the x plus 1. It looks just like this graph, only it's shifted that way. All right. So -1 would be 1, and 0 would be 3. And then 2 would be, let's see, 0, 1. 1 would be 9. So it would look like that. So it's just like this. I'm going to shift it that way. Yeah, I'll make the table. Yeah. X will say -2, -1, 0, 1, 2. Let's do 3. So y is equal to 3 to the x. And then y is equal to 3 to the x plus 1. All right. So -2 would be 1/9. -1 would be 1/3. 0 would be 1. This would be 3, 9, 27. Okay. This 0 would be 3. That'd be 9. That'd be 27. 3 to 1, 8, 1. So -1 would be 1, and 2 would be 1/3. So it's shifted. Oh, everything is shifted over. Helpful? Oh, you're welcome. Any other questions? Okay. All right. Uh-oh. Okay, I need to figure that out. All right. So I'm about to retire for the evening. If you have any questions, you can hit me up on those. And then, but the earliest I'll be able to respond is like 8 a.m. So if you're working on the middle of the night, I won't be. I'm gonna be asleep. But otherwise, just let me know. All right. So have a good evening. Unless you have any other further questions. You're welcome. My pleasure to help out.